This is just going to be a bit of a summary video on what we've done so far, where we are, and I want to give you a basic presentation on how we can present the tools that we're getting right now. And that being said, not all of the tools I'm going to show you are in the toolbox yet. But remember, we have this technical resources page. I want you guys to just remember to visit that, and you can download the most updated script, which these videos all, you see the numbers, all correlate with the script, the models. So they show you how to run the models or how to modify them if you need to. Okay, so just remember to keep looking at that, and I'll also even post this video on here and some additional tools that I'm going to present to you right now. So let's close that guy and open this guy up. Okay, so um, this is just a basic tutorial or basic presentation on what the data that we've got. I'm not a presenter. I don't often present this, so I don't have all the words prepared. But I want to show you the information that you can draw your own conclusions and how to present as well. But I want to just give you the tools that you're going to need to know. So, what is green infrastructure? That's just the first question we might want to ask, and why we're doing this. So, we also would talk about trees and their ecosystem services, why trees are important. A lot of it is stormwater uptake, it provides shade, a lot of reasons. There's several presentations on exactly this topic. But now let's go into the actual mapping. So, mapping the tree canopy. So we are right here at this point. So methods used for all of the projects that we've done, we use NAPE, that's 4-band leaf-on aerial imagery, and it's 0.6 meter resolution. It comes from the agricultural NAPE, National Agricultural Imagery Program, and that's from the U.S. Department of Agriculture. For some of the projects, we had LiDAR data, which is absolutely improves the accuracy of the tree canopy by a long way. Not all of our sites had updated LiDAR. Some of them are 2010 or even older. If your LiDAR is within a couple of years of your NAPE, it's very useful to use. I still have provided the videos to processing the LiDAR and how to create the tree canopy using only the GIS tools if you have LiDAR data available. We can talk about the methods. Each one of the towns we've done has been a little bit different, so I'm not going to go into the methods that you've used. But another important data layer is existing vector data. So if you have LiDAR and existing vector data, that you can count on your tree canopy being pretty accurate, very accurate, and then the additional data would match basically the existing vector data. Sometimes you'd have to update spots. Okay, next, I would present, it's always a good idea to present the challenges that you had in the land cover mapping, because mapping the land cover is an estimate. As much as people like to think that you can get 100% accuracy, that's not the case. There's a lot of reasons why we can't. One being shadows. The low sun angle in the South Carolina images for some reason is higher than it is in a lot of the other places I work. Further inland, it seems it might be a little better. But for example, you look at this image, you can see this is all very dark. And it's basically obscured in the classification. There are methods to pull it out, but that's not always easy when we're doing a land cover classification. If we have LiDAR, though, we can get an estimate of what's green, because you see, even if it's a field, we're still going to be able to tell that it's a field when we do some NDVI processes. There'll still be a little bit of the shadow effect, but if we have LiDAR data that tells us the feature height, we can say if it's green and if it's above 10 feet, then it's tree canopy. And if it's above 10 feet and it's not green, then it's a building. You see here. And you can also find pervious surfaces the same way, just in that query. But it's also very important to have existing vector data, because roads is super important to have roads and buildings. That really makes your classification much better. But if you don't, you don't, and you can still have a pretty good classification without it. And I think in some of the projects we've reached a pretty good data set. Although I do admit those shadows have been a difficulty in some. Uh, so the next thing that would be important to present is just this: the first number that you would get, or the first numbers that you would get, and this is just the land cover classification. So results in important numbers. Percent tree canopy, for example, it's 36% in this town, Greenville. So that combined tree canopy over imperv, and if there's any wooded wetland. So remember that. And then when we calculate this number here, this 36% tree canopy, we always want, that's truncated, we always want to exclude the water in the calculation. So you don't count the water in the denominator, and wetlands for that matter, because trees can't grow on water or wetlands. So you drop water in wetlands when you calculate the percent of your area that is tree canopy. That being said, sometimes we present it like this, so you can show cumulatively what your land cover is in a certain area, and we might include water in that. But usually when we present the number, the percent tree canopy, we don't include water in the denominator. That's up to you. It's just important that everybody is on the same page. Okay, so the next thing we would want to look at is in a tree planting campaign is how much can we actually fit. So we're going to want to set goals, and to do that we need to create a potential land cover layer. So we take our NAPE leaf on imagery and we create our land cover. That's where I just showed you the land cover for the town of Greenville, and it's 36.2% tree canopy. So we've got our land cover. Then we want to look at possible planting areas, and I'm going to go into this a little bit more detail in the next slide, so I'm going to breeze through it right now. It says possible planting areas. We've called it both. Possible planting areas, potential planting areas. You want to find places that are, one, pervious surfaces. Sometimes we include bare earth as well. Sometimes you might even say you want to plant where it's shrub. But for this purpose, we're going to take pervious surfaces and we're going to say those are possible to plant in. However, there are places that you're not going to want to plant that are pervious surfaces. So that's going to include like fields, ball fields, golf courses, school grounds, and it can also include areas that are underneath utilities like power lines if you've got that level of data. And it can also include you could buffer away from any road or water features as far as you want and count them as exclusions. Then you would intersect those, as I've showed you in other videos, with the pervious surfaces, and what's left is our possible potential planting areas. The next thing we did is there's a script that we can use to create our potential planting spots, and it also creates our potential canopy area in that process. So the potential spots, we use 20 and 40 foot diameter trees, and that was just based on observation. A lot of the trees where we work are between 20 and 40 feet once fully grown. There's possibilities to bring this model further, that we could look at the tree canopy as the tree grows. Right now we just have it as full grown, 20 feet or 40 feet. The priority is the 40-foot diameter tree. We drop the points, prioritizing the largest, and if it doesn't fit, then we go to the next smaller size, in this case the 20-foot. So we have our potential planting spots at that point. Then we do a buffer around them, that given size, and we come up with our potential canopy area. There's some details in here that I'm glancing over. For example, the buffer or the tree planting points are spaced 30% shorter than 20 and 40 because we want to have a 30% overlap once the canopy is grown back out, and that eliminates the holes between four circles. If you have four circles in the middle, there's going to be a little bit of a hole. That eliminates that hole. And also trees have a bit of overlap. At least that was based on the observation that we were making during the project that we wrote that script. That could be edited if we wanted to, by the way, or if you want to, you've got the model. So the potential canopy area, that's from that we would create our potential land cover, and we can use that potential land cover for calculating similar calculations as we do with our original land cover. And we can also have the same legend, tree canopy over impervious, because that buffer and overlap, we're going to get tree canopy over impervious. And for stormwater analysis, those are important numbers. Okay, so um, let's look at these. So creating the PPA, the potential planting areas and the potential planting spots. So just as I just said, pervious surfaces such as grass and sometimes bare earth are eligible, and then exclusion features are dropped out from that. So then we create the potential planting spots and we get a potential canopy area. And this is what our potential canopy area looks like. It looks pretty real. I mean, it's pretty cool. I see we've uh, drawn an exclusion around the baseball field, and once you've gone through these models, it's always easy to find a lot of places that you would have made edits. A lot of places. Um, I see them now. But anyway, that's close enough. It's good. I think this will be pretty accurate model if you guys see Greenville. It was a good data set, really good data set. So that's our goal setting. That's what we're gonna creating the data sets that we're gonna need to do our goal setting and select priority areas. So we've created our potential planting area data set. So the result of that potential planting areas data set is going to be some important numbers. So one of the most important numbers is the area. How many acres would a city want to plant? Now this is if they plant 100% of that potential planting area, which is not recommended. There's reasons in other presentations that it's an unrealistic goal. Of course, you're always going to want the exclusions, the baseball fields and such. But for this area, we've found that there's 876 acres of land that could be planted. So that's 4.6% of the land area can have trees planted on it. So that's a conclusion that we found. So that'll be an important number, the PPA, the both percent and the number of acres of potential planting area. So there also another question is going to come up is how many trees is that going to require? So in that 800 some acres, we can see that there's going to be over 100,000 trees that could be planted. That's 60,000 small ones and 40,000 large ones. And that's a little washed out little image, but you can see the potential planting spots and around the edge, the smaller ones to go around. And remember, this can also be intersected with stratification units, which we're going to go into next. But another result of that potential planting areas data set is our potential land cover. And from that potential land cover, we obviously get our potential tree canopy, which is 43.2. So I remember we said it was 30. Well, it's funny. I think I had 36.2 before. 36. That was just my rounding problem, probably. So 36.2% tree canopy was our previous tree canopy, and the potential tree canopy is 43.2. So that means that we can have an increase across the town of 6.9% tree canopy. And again, these can be now stratified based on certain measure units. So different organizations, different processes call them different things. Measuring units, zones, stratification units. An example would be like watersheds. You've got the entire area is covered in a watershed, and same as census blocks. The entire area is covered, and there's no place that's not covered in census blocks. So those are really good stratification units. Sometimes neighborhoods work really well also, and the places that are not a neighborhood, like a little larger than the public right-of-way, but public areas, basically right-of-way and public areas, you could count as its own little neighborhood, the whole entire, well, a large neighborhood, but it would be a calculation for the entire area. And the idea being is that if you have a neighborhood and you know the percent tree canopy, then you can approach the community at that neighborhood level because you know their percent tree canopy and you can compare them to other neighborhoods. Watersheds, on the other hand, might be a little bit more of a hydrologic type analysis where you want to find watersheds in entire basins, and you want to analyze the basin based on its percent tree canopy and its imperviousness, and maybe even go into this or trees and stormwater analysis, which would calculate the amount of runoff and such, and watersheds would be more applicable. Similar to neighborhoods, census block groups are useful, and the main reason why is because there's a lot of demographic data that goes along with it. If you have an area that's large enough and you have several census block groups, it really makes it easy to compare. I found like 5 or 6 census block groups make it easiest to compare, maybe a little more, 10, to compare across each other. So the main one that we use, one being race, a lot of times African American communities have less tree canopy, especially in cities. Interesting, many reasons why. Also, lower income areas have less tree canopy, and those might be analysis that you want to you could bring to the communities and ways to push your city or town to plant trees in certain areas for quality of life type value. So census blocks would be a good measuring unit or stratification unit at that point. Okay, so the next, let's see. I'm going to show you a couple of examples of our neighborhood. So this is the area of interest, and this is the same slide I showed you earlier. But it's important to calculate all your numbers for your entire area of interest in addition to your stratification units. For a few reasons, you can use those for the goal setting. Say the city has 30% tree canopy. And you might want to say you don't want any neighborhood to be less than 30% tree canopy. You can use those numbers to your advantage. So anyway, the point being is just remember to calculate that AOI value. And the one reason why I mentioned this specifically is because I like to calculate my AOI number before I calculate any of the stratification units, because after that I always make sure everything adds up to that one AOI. And you might see that in some of my other videos. I don't know if I've made those yet. I will. We're on 17 minutes. We are moving through. We'll get through this in 20, I think. So we've got our measuring units. Our AOI is the main measuring unit. I'm guessing 25 at this point. Sorry, guys. So we look at our neighborhood. We've got our current percent tree canopy for the neighborhood. And this number here, because we have the percentage up here in each one of the neighborhoods, we've got the percent additional possible. So if we were to look through this, we'd say, okay, oh wow, West Greenville has 11% of the area that they could add their tree canopy. That might be interesting. Where is West Greenville? See if I find it easily. It's at 25% now, so it could get up to 36%. That might be a priority area that you can use to talk to that might be a number that you can use to talk to that community and bring up their tree canopy. You would also want to look at the percent imperviousness and such. But they've got 11% available, which is a lot. So they must have some sort of large grassy fields. If it's super high, sometimes, by the way, like southern side, I would want to see why it's so high. Maybe I missed some exclusions. Maybe there's a big school or baseball field or football fields that have a potential planting area on it. You see, you'll always want to look at that, and that's the benefit of having everything scripted, so you can go back and revisit. So run right through the script again. So keep everything tight. Try to do as few things by hand as possible, because at least you're going to have to go back and go around as you find your edits after you've run through the steps. And so it's just without doubt you'll find some. Okay, that we used our median household income, or this is a map for the median household income. This is using the census block. See, Greenville, the town, it worked really well with census block groups, and we've got the median household income, and we want to find the areas that are lower than the median. And then we also, I represented this map as the watersheds because I wanted to show you what the watersheds map look like, but we also mapped the percent tree canopy by each individual census block as well. Now, watersheds at the town level, even sometimes they're pretty simple. So like this is the National Hydrologic Database HUC 12. That's the most detailed you get, HUC 12. But I've found that there's NHD Plus has a catchments data set that can be used directly, or it can, smaller polygons can be eliminated. You can use it for a base for a better catchments data set if your town doesn't already have one. But I just wanted to show you catchments are a good way to measure because there's going to be values that are going to hydrologic values that we're going to calculate some numbers that'll be important to hydrologic principles, to keeping a watershed healthy, I should say. Okay, so another one is tenure, public versus private. I don't have a map to represent that right now, but public versus private is good. So next one, the measuring units, or like this is the same measuring units before I called them stratification units. You see, that's why I kept this over here so we can refer back. I wanted to refer to these separately because I don't think of these the same as the stratification units. But these are indicator type features like river buffers. A town might have laws saying that they have to have 100-foot river buffers. Roads also, we do a 50-foot buffer from the road center line and we can calculate the percent tree canopy within 50 foot of the center line, and that's just a good indicator. If you stratify that across your stratification units, you might find neighborhoods that have lower street tree canopy, and they might be targeted. Bus stops, trails, bike routes, any other kind of infrastructure value. And then there's the cultural significant type amenities measures, which would be parks, schools, and historic sites. See, these really aren't zones or stratification units. These are features and amenities. Okay, so measures, the indicators, calculations, and comparison data sets. So I've already mentioned all of the data sets, but now I'm going to just show you. I might not have mentioned surface temperature, but now I'm just going to show you what they look like. I'm sorry, I'm going to step back, and we're still in this block, and now I'm just going to show you the map. So the percent street trees, this is street canopy within 50 feet of the road center line. Now, I like to represent the interstate, but I've been asked not to represent the interstate because, of course, we would never propose planting trees on the interstate. I just like to see I just like to see something with 0% because it's the best reference. It's just an opinion. Bus stops as well. We can map what's within 50 foot of a bus stop. We've gone up back and forth on the 50 foot as well, but we've decided that seems to be the best metric. It's we always use 50 feet, and that's just makes it easier for us to interpolate. Some you might want to use different numbers. You can edit that script fairly easy. Okay, so other measuring units. We've got our parks and trails, and we've got calculated those parks and trails, the percent tree canopy, the possible tree canopy, and the opportunity, the difference. Wow, some of these are incredibly hard, but high. But railroad mini park, I'm assuming that's all. There is no tree canopy there. So parks sometimes are interesting because not all parks you want to have trees. But this is just some maps that represent that. And another one of some historical districts that we pulled out separately just for the community to look at. So these are all tabulate area type commands using your vector, zones, or features data set, amenities, either one of these, and just a tabulate area. And horizontal statistics, either one of those works. Usually it's tabulate area with my stratification units, and it's a zonal statistics with the parks and historic districts and such. But we have other videos that have those actual models that we go over. Another data set that's important to compare that we found is really useful is surface temperature from Landsat. So the latest, it's best definitely Landsat 8 because you don't have the banding problem. Um, and you want the analysis ready data set when you're looking at that on the Earth Explorer. So ARD, Earth Explorer. And usually it's best to compare the summer months when it's going to be the temperature is going to be the hottest. Uh, okay, so that's surface temperature. By the way, I just have to mention, sometimes it does depend, it's relative, it really does depend on when the surface temperature was acquired, because if it was in the morning, your surface temperature is going to be lower. I've got some other areas that it goes up to 115 or 120 degrees, but I'm pretty sure it was more towards the middle of the day that it was acquired. That's my guess. And so the temperatures are higher. That's the guess. It comes in Kelvin. The script I've given you converts it to Fahrenheit. Okay, so now we could compare our census data, like the median household income. This was the projected number from 2017, and the percent tree canopy. And you can see that the tree canopy goes up with the um, income. That doesn't always happen, but it is interesting when it does, and you can show it. Um, another Another thing we would show, we might represent, is the average surface temperature of the census block group, and versus the census block's percent tree canopy. So you can see where there's low tree canopy. Uh, this looks like my circles are a little bit shifted. Where there is, yeah, they definitely shifted. Sorry, but I can't redo this whole video for that. So you'll want to see where there's a low percent tree canopy. There's usually going to be a high surface temperature, and that really works for showing to your communities what's going on. And to represent it in a table or a chart, you can really see that trend. I mean, really, really is amazing. Interestingly enough, though, in some places there are not with surface temperature. With income, it's definitely different. Yeah. When you're comparing these income, it doesn't always match. Uh, for example, in Florida, we found that there were some places that were the lowest tree canopy had the highest income. And can you guess why? Golf courses. I thought that was kind of interesting because they have golf courses through the middle of the neighborhood. So they had low tree canopy. So benefits are typically modeled on a tree by tree basis. So we need to analyze trees based on conditions, and for example, the hydrologic soil group, and how the hydrologic soil groups are based on how much moisture or how much water they retain. So if we overlay our land cover with the hydrologic soil groups, we've created a lookup table that can allow us to calculate where, if there's tree canopy, what would be the impact if that tree canopy were removed. And we use a 2-inch storm event to calculate that. See, then you could then stratify this or calculate these numbers based on your stratification, and decide exactly how much water is saved or is kept from entering the storm system, or how much could be. So there's the optimal tree planting locations where you might want to add, uh, so or where if trees are lost, how much it would impact. Um, okay, so then the only other one, and we are at 29, so I'm sorry I've gone way over. The only other data layer that I want to show, and I'll do another video on this one, is eye tree calculations. If you wanted to calculate air quality benefits, there's just calculation numbers, and iTree, it's difficult to get it to just produce you a lookup table, so I'll show you how to do that in another video, and that'll be available in the links. So that's the iTree calculations. I'm going to do another video on the trees and stormwater calculations, and surface temperature, And I'll show you how to download and find the proper attribute tables for the census plot groups, because that's not always the easiest thing to do. And then in addition, there'll be one more. I think I'm just realizing now, I'll do one more model that shows how to just calculate the tabulate areas uh, or the zonal statistics to get the numbers that you're going to want to put in there. And that's going to be it. That'll be everything for the tree campaign type analysis. We can talk about specific issues one by one. Uh, Let me know. Send me comments. And thanks for your patience. 30 minutes and 40 seconds. Stop.